And I said I've spoken about partial discharges. Has anyone here had any experience with partial discharge? Any comments on partial discharge? Contaminated bushings, obviously a big problem. So obviously, if you analyze the waveforms, you can detect obviously inside the solid insulation between a conductor and a solid insulation, surface tracking, arcing and sparking. Has anyone had any issues there? Short-term monitoring of partial discharge, or you can do semi-permanent monitoring. It's a bit more expensive. And obviously, continuous monitoring would be really good for partial discharge. But obviously, that can be quite expensive. Partial discharge levels you would have are low, moderate, elevated, and critical. In switchgear, you can have locations which you could see partial discharge. Has anyone had any issues with partial discharge? Any issues? Steve, any comments from you on partial discharge? Richard? You can get it from internal faults in your VTs, your potential transformers, bus bar support insulators, cable terminations, through bushings, obviously internal faults in CTs. Where the conductors at a medium or high voltage is close to earth metal, surface contamination, which good old moisture, as Steve mentioned early on. Your conductor's got under a floating potential, arcing contacts, isolating contacts, loose connections. These are all potential areas for partial discharge. There's a sort of diagram. And then obviously you can do testing with various, okay, yeah, thanks. A little experience, yeah, knowledge of. So you can do testing with acoustic methods. There's a discussion there on acoustic methods. Quite useful. You obviously don't want to take a switchgear offline. There's an example of one. Crack bushing in an equivalent circuit. Here's tan delta. Increase of tan delta with voltage. High current contact resistance test set. Limits, here's some suggested limits for contact resistance for circuit breakers. Typical things in vacuum or oil. Oil is obviously not as important today with SF6. And here's some more suggested limits, which we have. Obviously, quite important to track that over time. Thermocam, as we say. Trip coil monitoring is another issue with maintenance. Obviously, the last thing on your mind, sorry, okay, can you increase your volume? I'm sorry if I'm very faint. Let me just turn up my volume. I'll just talk a bit louder. I'm sorry if it's very faint. Hopefully you can hear me now. Obviously, trip coil monitoring is very important. This is probably one of the greatest possibility of a failure is when your trip mechanism and trip coils fail, often due to, believe it or not, improper lubrication. You can actually see it happen sometimes in an Arctic environment, very cold, or worse is just the oil's old. So you can get shorter turns in the trip coil, mainly due to deteriorating winding insulation and obviously faulty secondary wiring. So those are things that you need to check. So seized bearings, defective latch mechanisms, and one of the worst things, which hopefully you don't have in a marine environment, is corrosion. And obviously, if you've got untrained people making incorrect adjustments, that's also another potential problem. People don't work on circuit breakers all the time, and often the training is a bit weak. So the other thing is your circuit breaker should be speed time tested when first installed, and it should trip at 70% of battery voltage. So very important. That, and your trip pulse is normally about 500 milliseconds. So you have trip circuit supervision, constantly supervising integrity of the trip circuit. Really important. That says a typical example here. Not more than 0.5 of a second, and obviously there's your phases stripping out. Trip coil tester is a typical tester that you can use to testing. Very important. as I say, it's one of the areas that you could fail. SF6 gas monitoring is obviously dependent on the purity of the gas, and of course, inevitably, your purity degrades with oxygen, moisture, and acidity. Sorry, excuse my pronunciation. Mainly hydrogen fluoride. So those are obvious issues. So very important to keep an eye there on what's going on. Switchgear maintenance procedures really are a combination of generic requirements and obviously type specific. In other words, we can talk generally about switchgear maintenance, but also you need to look specifically at the type of switchgear you've got. Generic sort of instructions are, for example, lighting, portable lighting required, tools and equipment, safe working, environmental protection, protection from other live equipment. That's your generic maintenance instruction. Cleaning materials, unit identification, cleanliness, cleaning down oil-filled switchgear, avoiding moisture getting in or windborne iron dust, and then solvents that you're using. So obviously very careful about which solvents you use, because some solvents unfortunately destroy your insulation, which obviously you want to avoid at all costs. Then there's obviously maintenance that you need specific to your switchgear, such as the position indicators, oil level indicator windows, what you should be looking for, arc gaps, bonding continuity with earthing or grounding, shutters and locking devices, and interlocks. So you need to have a knowledge of the interlock requirements. Here's a few more suggestions. Ventilation for that specific switchgear, functional test. These are all sort of issues relating to a specific item of switchgear, which the manufacturer will tell you, but you need to know exactly what he or she means. Other items are test access covers, fuses and fuse holders, fasteners, weather protection, and obviously note on PCBs, which obviously hopefully you don't come into contact with. They're carcinogenic. Problems that may be found during switchgear maintenance, I don't know if anyone here has had any of these sort of problems. Inspect for keys, bolts, nuts, cotter pins that have come loose. I've seen on some very old sites, 30, 40-year-old sites, sometimes you see very strange things amongst your switchgear. Obviously look for wood operating rods, guides that have come loose from clamps, and obviously other potential issue when you've got a lot of vibration is you've got welds that have come loose. Obviously, hopefully you don't have that, haven't had those problems. Problems that are obviously found are look for contact burning. Contacts need to be reshaped or replaced. That's mainly OCVs, oil circuit breakers, and densified wood, where they've absorbed moisture and they start to track across the surface. Those are all potential problems. On oil switchgear, which I don't think many old sites have them, but you probably won't come across it that often. Look for carbon or sludge and burning and oil erosion. And look at the bushings and gaskets, and they're in good condition. So those are sort of things you'll be inspecting for. Oil testing is really important, done by a proper lab. It's always quite interesting, actually. Oxidation can occur, so you get, because of the high operating temperatures, and that, of course, causes sludge, which is public enemy number one, which causes your oil dielectric, the properties of the oil, to deteriorate. So obviously very important. Oil dielectric test we just discussed here, very important to do it properly. Looking at breakdown voltage. Acidity is another issue. Acids formed, so you obviously need to watch out for that, and obviously check what your acidity is. Interfacial tension test. This where you put oil on water, looking for a minimum surface tension, looking for 50 dynes per centimeter, making sure it doesn't go beyond that. This is sort of a typical issue that you're looking for. Color, quick way of looking at the oil. Different colors that you have to actually indicate the deterioration. Specific gravity is another test. Very important, as you know, with batteries. Other tests, obviously, flash point, viscosity, pour point, resistance. These are all very important tests give you some indication. So I don't know if you can see this here, but there's an action diagram for a type-specific switchgear defect. So there's a whole process you go through depending on the safety issues. So you can go straight down if it's fairly safe, or you track different ways here. So for example, found a specific defect, you identify all the locations. Does the defect make the switchgear dangerous to operate? That's a very important question. If it is, then you obviously need to take it out of service as quickly as possible before someone's hurt. If it's not, well then you can basically say, does the switchgear prevent switchgear automatically interrupting the faulty current? No? Well, great. Continue using it. If yes, then you need to get a remedial program in place as quickly as possible. So these sort of logical, systematic approaches to your maintenance are very, very important. And obviously, just a final few words about switchgear installations. Obviously, one of the issues here is rear access, work on main contacts, failure to lock. Very important that you handle those sort of issues. I was talking to a few guys a week ago about arc flash issues with switchgear. Obviously, you want to avoid any possible injury to anyone working on them. And safety mechanisms are very important to deal with those properly. If you don't have training specifically in that area, you can have potential problems. Phasing out. And obviously, the other issue is fire protection. In substations, check that your fire protection is still in operation. That's obviously very important to test. It's quite frightening how people often don't inspect this sort of thing, but not necessarily particular to electrical, but very important to know about. So that, in a nutshell, is a very quick shoot through the topic that we've been discussing here, and as I said, really just trying to give you a very quick outline. Some thoughts. I don't want to burden you with thousands of words, but just testing and maintenance of electrical equipment, and obviously just to go through some of the issues to consider when you're next working on your switchgear in your wonderful new substation, or in most cases, unfortunately, your old substation, which is a little bit hammered by the weather and the dust on your mine or in your town. So just from me, any comments from anyone else here? Let's ask first of all, I don't know if Steve's still with us here. Steve, any comments from you? I'm delighted to see that you stuck it out here. Thank you very much. Steve, please don't embarrass me. I did a very, very quick presentation on some of the issues, but it's very kind of you to hang in there and listen. I'm sure you know probably a lot more than I do. Carol, any comments from you?
No. I think it was a good session. It's a shame that we lost our connection briefly, but everyone will get a copy of the recording and the slides. I don't know if there's anything extra that you'll be sending out on top of that, Steve.
There's a very interesting chapter actually on the testing, which I just want to send out from our manual. So I'll put that in the slides. There's actually a really good chapter on testing. It's about 8 or 9 pages. So if I can just include it in the pack before you send it, I'll grab it tomorrow out of the manual. It's a PDF file, and I'll make sure that you guys get a copy if we can send it out. It's just some of the issues with testing, which I must say I haven't been involved at that level of testing, but it's quite interesting. Unfortunately, there's a lot of the old experts have left site, so the maintenance today is often a lot more brutal and simple. But thank you very much, Carol. Yeah, I'm sorry to drop out. I'm very interested, actually. Emil, maybe that's something you need to look at, because we both dropped out at the same time. And as you know from the CIA spy thrillers, there's no coincidences in life, unfortunately. So there's obviously something really interesting happened there that we both dropped out at the same time. Something very interesting. But anyway, that's all from me. But thank you very much, everyone. You will get a copy of the slides and this extra chapter on testing, which I will include tomorrow when I get to work tomorrow morning. Thank you so much for coming along. As I say, it's designed to be as quick as possible to keep you on the with us all. Thank you very much, all of you, and thank you so much, Carol, for choreographing it and handling it. I see Neil says there is a little bug which he's detected. He's just sent me now. So that's good. Thank you, and thank you very much, Ahmed, Alexio, Andrew, Madhu's son Mulik, Mogabs, Richard, and Richard Schneider, and Sean, and Steve, and Carol for attending. I really appreciate it. Thank you very much for coming along. All from me, and I hope you have a wonderful afternoon or night.